one more introduction to the same idea, impulse, but with graph. I have done this, but anyways, officially I have to put it across. So first case is case we have a constant force applied from time t1 to t2. So what we have here is okay. So what we have here is forces so basically constant force acting from t1 to t2. So this is your force, that's your time, and yeah, I'll name them. I think it will be helpful. So OA, BC, or that's OD, ABCD. Now we have already spoken about it. So what is that? How is that we'll be able to figure out force with force and time graph? How is that we'll be able to figure out impulse? Is it not area under the curve? So area of rectangle, it has to be a rectangle because you have a constant force, right? It's a constant force. This indicates constant force. Area of rectangle ABCD is equal to AD into dV, which is AD is what? It's the constant force, right? And AD into, not dV, sorry, DC. And DC is what? DC is your T2 minus T1. So you can see it's leading to the same idea. So this is F times of delta T. This is nothing but magnitude of impulse of force F in the time interval of delta T. Magnitude of this formula you guys know, impulse of force F in time interval delta T. Right? So basically what we're trying to tell is if we have a force time graph and you know the constant force or the average force, right? Any graph like this, it's a simple figuring out the area of the rectangle. That's it. That's all it means. Nothing fancy happening over here. Of course, more realistic one is what we're going to see in the next section. That is case of varying force F is applied from time t1 to t2. This is what happens, right? So this is basically what's going to happen. So we are looking at a case wherein we have varying force. And so your graph will look like this. And we have T1, T2, A, B, and C. This is time, this is force, and this is the area under the graph. Okay, so clearly you can see that force is varying. So we have varying force in magnitude acting on an object from time T1 to T2. Now, impulse of force F in the time interval, in this time interval, is given by what? J is equal to T1 to T2 F dt. Right? Why are we using integration? Because the force is varying. It's varying as a function of time. So this again is nothing but your area under the force time graph, which we made a point pretty much from the start of the impulse topic. In our case, ABC. In this case, it's ABC. So it's the same thing again and again, guys. Literally, there's nothing happening. It's just that we need to introduce, we have all of this, you guys need to get exposed. But of course, if you understand thumb rule, if you understand integration, if you understand basic statistics, basic area concept, you're pretty much done. If you just understand all of the basics, impulse is a new definition, apply it to that and you're done. All of these cases is just a formal introduction to all of that. So this is also possible, and it's there is what I'm doing over here. If not, honestly, it should be very commonsensical to you guys. Okay, so you guys can write these headings and you need to copy this, and we will start off with few numericals.